As we all know, a potential difference is set up across a conductor. The current flows through it. A German scientist, Georg Simon Ohm, by his experiment, found a relationship between the potential difference and the current in a conductor. This relationship is stated in the form of a law which is known as Ohm's law. According to this law, the current flowing in a conductor is directly proportional to the potential difference across its ends, provided the physical conditions and the temperature of the conductor remain same. To verify this, the experimental setup is arranged like this. The circuit consists of a rheostat, a key, an ammeter and a resistance wire connected in series with the battery, and the voltmeter then connected parallel across the resistance wire. The battery sends current in the conductor and the current in the circuit is controlled by the rheostat and ammeter measures it. The voltmeter measures the potential difference across the ends of the resistance wire. First, the key is closed and the rheostat is adjusted to get the minimum reading in the ammeter and the voltmeter. The sliding terminal of the rheostat is then moved to increase the current gradually, and each time the value of current flowing in the circuit and the corresponding value of the potential difference across the resistance wire is recorded. Then for each set of values of I and V, the ratio of V by I is calculated. It is observed that the ratio of V by I is almost constant, which gives the resistance R of the wire. But once if the temperature of the conductor varied due to the flow of current, then this relation will not hold. That means this relation holds only when the temperature of the conductor remains constant. So that is the limitation of this law. Ohm's law is obeyed only when the temperature of the conductor remains constant. Hence we can conclude, according to Ohm's law, the current flowing in a conductor is directly proportional to the potential difference across its ends, provided the physical conditions and the temperature of the conductor remains constant. The direct proportionality between current and the potential difference implies that if the potential difference across the ends in a conductor is doubled, the current flowing in it also gets doubled. That is, if a current I flows in a conductor, when potential difference across its ends is V, then according to Ohm's law, I is proportional to V, or V by I is a constant. This constant will be equal to the resistance of the conductor. Thus, if a graph is plotted by taking V along y-axis and I along x-axis, which is found to be a straight line. We have already learned in 9th standard in that graphical representation that if y is proportional to x, then the graph will be a straight line with a slope. So here V is proportional to I, so we will get a graph which is a straight line, and the slope of the graph gives the resistance of the conductor. Here, if I is equal to 1 ampere, then V is equal to R. Thus, resistance of a conductor is numerically equal to the potential difference across its ends when unit current flows through it. So, according to Ohm's law, the resistance of a conductor is equal to the potential difference across its ends when unit current flows through it. And the resistance of a conductor is said to be 1 ohm if 1 ampere current flows through it when it kept at a potential difference of 1 volt. Therefore, 1 ohm is equal to 1 volt by 1 ampere, or 1 volt per ampere is called 1 ohm. In normal conductors, as temperature increases, the resistance also increases. Hence, if we plot VI graph of a conductor at two different temperature, the steeper graph represents the higher temperature since it has more resistance. So steeper the graph will be higher the temperature. Later on it is found that this Ohm's law is not applicable for all conductors. So the conductors are divided into two categories on the basis of Ohm's law. The conductors which obey Ohm's law are called ohmic resistors or linear resistors, and the conductors which do not obey Ohm's law are called non-ohmic resistors or non-linear resistors. Hence, ohmic resistors obey Ohm's law, and VI graph of all ohmic resistors are linear. For example, the metallic conductors such as silver, aluminum, copper, etc., nichrome, copper sulfate solution with copper electrodes, and dilute sulfuric acid, etc., are ohmic resistors at constant temperature. In non-ohmic resistors, the VI graph will be non-linear or it is a curve. Example, diode valve, triode valve, junction diodes, etc. For all these conductors, the graph plotted for potential difference V against current I is not a straight line but a curve. Hence, we can differentiate ohmic and non-ohmic resistors in such a way that ohmic resistors obey Ohm's law and non-ohmic resistors do not obey Ohm's law. The graph for potential difference versus current is a straight line for ohmic resistors, and the graph for potential difference versus current is not a straight line for non-ohmic resistors. The slope of VI graph is same for all values of V or I at given temperature in ohmic resistors, and the slope of VI graph is different at different values of V and I at a given temperature in non-ohmic resistors. Now, if a conductor has high resistance means it has less conductance, or a good conductor has less resistance and a bad conductor has more resistance. So, the reciprocal of resistance is called conductance. That is, conductance is equal to 1 by resistance. And the unit of conductance is ohm inverse, or it is also called Siemens. For a metallic conductor, the ratio of V by I is constant for all values of V and I. So, if we plot a graph by taking current against y-axis and potential difference against x-axis, it is called IV graph, and the IV graph of all ohmic resistors are straight line, but the slope of the graph, that means y-axis by x-axis, gives the conductance of a conductor. So here also for ohmic resistors, IV graph is linear. Now we know that the resistance of a conductor increases with increase in temperature. Is it? So the resistance of the conductor decreases with decrease in temperature. It is observed that the resistance of some substances like tin, lead, etc. decreases tremendously with the decrease in temperature and becomes almost zero in a very low temperature range. Very low temperature means it is a temperature range almost nearer to absolute zero, that is minus 273 Kelvin. The substances under this condition are called superconductors. Hence, superconductors are substances of zero resistance at a very low temperature. Example, mercury below 4.2 Kelvin, lead below 7.25 Kelvin, and niobium below 9.2 Kelvin are superconductors. But the superconductors are not common in use because it is very difficult to achieve such a very low temperature. But if it is possible to obtain the superconductance at room temperature, the size of the computer can be reduced to few centimeters and the power lines could be then made as thin as a single wire. Hope you all have understood Ohm's law. Thank you and have a nice day.